Assalamu alaikum. Today we will discuss about an important topic, register. What is register in digital electronic circuits and what is the use of these registers in our electronics? We know that flip-flop, this is a 1-bit memory cell, means it only stores 1-bit binary information. One flip-flops stores 1 bit binary information only. But what is this register and what is the use of this register? Register is a group of flip-flops. Suppose it is a group of flip-flops. Here are present many types of flip-flops and this group of flip-flops is called the register. Let's see why we use this register. Suppose if we think about the microprocessor or microcontroller, then we will find that it stores or processes the data in multiple bits, means it stores the binary information in suppose 16 or 32 or 64 etc bits, means it needs to store multiple bits of data. Then how this flip-flop will be used in storing this data information? As the one flip-flop stores 1 bit binary information, then if we have to store multiple bits, then we have to use multiple flip-flops in our device. So for this requirement we use multiple flip-flops for multiple data storing. Then this group of flip-flops is known as register. So this is why we use the term register. What it does? It to increase the storage capacity, means in some cases we have to increase the storage capacity, then we need multiple flip-flops to store multiple binary information, and this group of multiple flip-flops is known as register. So the n-bit register consists of n number of flip-flops, and here each flip-flop stores only one single bit, and they all share a common clock pulse, means for all these multiple flip-flops there is only one single clock pulse which is passed to every flip-flops at a time. Typically in this register, the D flip-flops are commonly used as a memory element. Different type of flip-flops is also used in the register, but typically this D flip-flops is used as the memory element because it stores only one input. It has only one input and it gives the output that comes from this only one single input. But if we use the SR or JK flip-flop, then we will have two inputs. Then this seems complicated for our device, but if we use this D flip-flop, then it will be more simpler. Now let's see register with parallel load. The transfer of information into a register is referred to as loading the register. What does this loading the register means? Means if we want to input some information into our register, then we will load the information into our register. This will called the loading the register. Let's see a block diagram of parallel load register. Suppose this is a 4-bit parallel load registers. So here we have drawn 4 D flip-flops and one same clock pulse is pushed in all the flip-flops at a time. And here these I1, I2, I3, I4 are 4 different inputs for these 4 flip-flops, as it will store different 4-bit binary information. So here will be 4 inputs in 4 different flip-flops, and this diagram will be called as a register. If all the bits of the registers are loaded simultaneously with a single clock pulse, here we have used a single clock pulse, we say that the loading is parallel. Means here we have seen that here the registers are loaded simultaneously with a single clock pulse, means the same clock pulse is applied to all the flip-flops and these inputs are loaded in all these flip-flops simultaneously. Then we can say that this is a parallel load registers, means it is in parallel series condition. There might be a question that why you use this load signal? What is the use of this load? Let's see the answer of these questions. Suppose if there is no load signal, then the registers always copies whatever is on the input to its internal storage at every clock pulse. see the diagram, here we don't use any load. Here we see that if we give I1 as input in this flip-flop, we will get this same input as our output from here. From the D flip-flop, we know that if we give A as our input, then we will get the same input as our output. So this I1 will be same as our output. Here this I2 will be same as our output from flip-flop 2. This is the same process. But if we want to store our old and previous values in our flip-flops, then what will be done for this? This will not fulfill our requirements, because at first if we'll give I1 as 1, then we'll get the I1 output as 1 from our flip-flop ones, and after that second clock pulse, if we get here 0 as input I1, then from this flip-flop 1 we will get 0 as our output. Means it changes according to our input changes. But if we want to store this previous one value as our output, then what will be done? For this purpose we will need the load signal. Without load signal, the data stored in the register changes continuously with the input, what we have said already. So let's see what is the problem at this condition. In the real digital system, we don't always want to overwrite data. Means we don't want to change continuously. And again, you may want to hold the current data until some control says new update. Means we don't have to take new updates, then we will want to hold the current data, and when we get the directions of getting new updates, then we will get the new updates. But if we don't use any load signal, then we can't hold the current data. See the table. Here the first clock pulse and here the second clock pulse. At the first clock pulse, we gave 1010 as our input for the 4D flip-flops, and we got the same as our output. And at the second clock pulse, we gave different inputs 1100, and here we will also get the same output that given into the input condition. Here this output updated from this updated, even if we don't need this update. If we want to hold this previous data, then this will be not useful for our storing previous data. Now let's see how this load solves our problem. With a load signal, the register only stores new data when you want it to. Means when you want to update, then this load signal helps us to store new data. And when we don't want to update, means we want to hold our previous data, then with the use of this load signal, we will don't take any new updates and we can hold our old data. Let's see how it acts. It acts control like when the load equals to 1, the register accepts and stores new data on the next clock pulse. And when the load is 0, the register ignores the input and keeps the old data. Here we have two functions. One is we store new data, and second is we will hold our previous data. This load fulfill our both conditions. If the load is 1, then the register will accept new data, and if load is 0, then the register will not accept our new data that is given to as input. The register will ignore that input and it will keep the old data. Let's think it as like a locker. The load signal is like opening the locker door. When it opens, means load equals to 1, you can put new books, means data, in the locker, and when it is closed, means load equals to 0, what's inside stays safe, means no new books can be kept inside the locker. This is how load works in register. Now let's see the functions of these things. What does register does? It stores multiple bits of data. What load signal does? It tells means it directs the register when it needs to store new data. And what does this clock do? It triggers the actual loading or holding. Let's see a table to understand it more clearly. Suppose this is a clock pulse. When the clock pulse is 0, this flip-flop will not work any new function, means it will be unchanged whatever gave it input in it or load in it. So if the clock pulse is 0, at that time if the load is 0, then no change, and if the load is 1, then it will be no change, because the flip-flop will be not worked in any condition as the clock pulse is 0. And at the condition of rising edge of the clock pulse, means the clock pulse is 1. Let's see what happens. If at this condition, if the load is 1, then the register will update it and new data will be loaded. And if the load is 0, then new data will not be loaded, it will store old data, means it will in the hold condition. So our all the requirements are fulfilled with the use of this load signal. Now let's see what is parallel load means. We will know that what the working function of load signal. Now let's see what is the parallel load. The term parallel load means that all bits are loaded into the register simultaneously when a control signal, means load, is active. At the time of load equals to 1, means load is active, then all the bits are loaded into the register simultaneously. This is why this load is called parallel load signal. Now, how to use this load in our circuit diagram? Here we have to ensure two conditions. We have to ensure that there will be no propagation delay, and in the synchronous system it is preferred that all the synchronous elements receive the clock at the same time. Means if we have any propagation delay, then all the flip-flops will not get the clock pulse at the same time. There will be some delay. So to avoid this propagation delay, we have to ensure that all the flip-flops get the clock pulse at the same time. Now let's see how data bits are controlled using load signal. What does this load do? This load mainly controlled our data signal, and let's see how data bits are controlled using load signal. This is a circuit diagram of resistor with parallel load using D flip-flops. Here we have used 4 D flip-flops and same one single clock pulse that is applied to all the flip-flops at the same time. Now let's see how this load works. As we have two conditions. One is we want to store new data. One means we want to load new data in our registers, and second is we want to hold our old data, means we want to ignore the new data. So let's see how the load should be connected to our circuit that will fulfill our both conditions. For the D flip-flop, this is the arrangement of circuit diagram. This is how we should connect the load into our circuit. Suppose this is load which is connected to the circuit, and here we have used 2 AND gates and 1 OR gates for 1 flip-flops. Let's see how it works. Suppose this is at the time of load equals to 1, means load is high. Then what will go here? One input will be 1 and I1 is our first input. Then here we will got, then as this input is 1 and this is our first input, then we will got the output of this AND operation as 1, means it will give the input of I1. And for this AND gate, if the load is 1, then after using this NOT gate we will get here as 0 as our load. Then this 0 will come to this and suppose here we will get something outputs, and this output will get into this AND gates, and here it comes 0 into as input for this AND gates. Then for the AND gates we note that if one of the inputs is 0, then the whole output becomes 0. So here the output is 0. And for this AND operation, as we got 1 and 0, then we will got the 1 as our output, means we will get the input I1 as our input, and as we have got the 1 as our output, then this means this flip-flop will store new data. This flip-flop will be loaded with the new data I1, means from the queue we will got our new data I1. And let's see when the load is 0. When the load equals to 0, then we will get here as in 0 in this first AND gate, and I1 is our input as before. And as one input is 0, then the output of this first AND gate will be also 0. And for this second gate we will give here as 1 because load is 1, and after the NOT operation we will get here 1. Then this 1 input will come through this second AND gate, and something that output will be come through this. As here this is 1, then we will get here as 1, and from this this one means this will stores our this old q out means output, and from this it comes 0 and here comes 1, then we will get 1, but it is for this old data means this old output. Then actually this I naught will not be go through this input, this previous q will be go through this or gate, and then we will get the output as our previous data means it will hold our previous output. This is how we can control our data means we want to store our old data, then we will get the load as 0, then it will store our old data and it will ignore this new input. And if we want to load our register with the new data, then we'll get the load as 1, then it will ignore this old or previous data, it will give our new data and it will be loaded with the new data. This is how all the 4 flip-flops works, and we can control our. So in the conclusion we can say that if the load signal is high means 1, then the data will be get loaded into the register. Only the clock transition. This works only at the rising edge of the clock, and if the load signal is low, then it will not be loaded new data, it will hold the previous data. This is how this parallel load signal fulfill our all the requirements. If here we use the clear input, then for the active low of this clear input condition, if the clear input is low means 0, then all the flip-flops are in the reset condition means all the flip-flop will be 0 and it will start taking input at the very beginning. So if we want to reset the registers means all the flip-flops, then we will give the clear as 0 in the input of the flip-flops. This is how the load signal works according to our control in the circuit diagram.